Welcome to the Trend Detection podcast, powered by Siemens, and now your host, Gagan Sanger. In this episode, we explore how predictive maintenance is reshaping the automotive industry, focusing on its adoption, implementation, and measurable successes. We'll uncover how attitudes towards predictive maintenance software have evolved and share success stories of businesses that have embraced it. From understanding the cultural shifts required to quantify the ROI of predictive maintenance, this episode is packed with insights that automotive industry experts won't want to miss. So, just want to give a warm welcome to our guest on this episode, Peter O'Hara. Thank you for joining me on today's episode.
Yeah, hello, folks. So, Peter O'Hara, I am a customer success manager here at Senseye, and I've been with the business just over 7 years. And one of the areas that I look at is after our automotive customers. So, somebody thought it would be a good idea to pick my brains about what's been changing over the last few years and what's coming up in the world of automotive and predictive maintenance. So I said, yes, okay.
Well, perfect. Well, thank you so much for joining me on this episode. And I'm really looking forward to going into some of the details and just, defining a few more of these areas around the automotive industry.
Mm-hmm.
So I just want to start off by asking, my first question, and it's really focused around customer attitudes.
Uh-huh.
So, from a customer perspective, how have, their attitudes towards predictive maintenance softwares in automotive industry evolved over the last, say, decade?
Yeah, this is quite an interesting question. I was asked to look up one of our first automotive customers and what they requested at the time, which was just about 10 years ago. And when I looked at their reasons for adopting Senseye, I was really surprised at how modern they seemed. So key goal, I suppose, reduce downtime. Obviously, everybody likes that. And they had a number in mind, so they wanted to reduce downtime by 50% to begin with. They wanted to improve their operating efficiency, and they wanted to reduce maintenance resources needed, both from a labor point of view and from a skills point of view. And then the thing that really surprised me, and again, talking about 10 years ago, they wanted a cloud-based system. So that seemed quite modern for me now, even though obviously we've been in this area for that amount of time. They wanted to make use of IoT devices. They wanted to make sure that they could inform production operations about what needed to be done and when. They wanted to be future-proof, and they wanted to have a global and a transportable set of standards that they could move from place to place. And I think if I was looking at that now, I would think that's quite a good place to start. We used to say we thought this particular customer was maybe 10 years ahead of the competition, and now I'm thinking maybe they were 15 years ahead. I think today you would probably want to add integration to a CMMS system. You would definitely want to be talking about language models and trying to use some of those tools to enhance their maintenance procedures. But I was really surprised at how almost future-proof they were, say, 10 years ago.
Yeah, I completely agree with you. And I would say, that is a pretty good shopping list,
Mm-hmm.
For anyone who is looking to start up, especially around this industry. And then, just from your perspective as well, Peter, in terms of, with regards to anything, there's always some form of, pros and cons. So I just want to dig a little bit deeper into some of the biggest hurdles customers are facing when it comes to considering predictive maintenance solutions.
Yeah, I think there's a few kind of like technical challenges and a few cultural challenges. One of the areas that I find almost odd in this day and age is that you do find customers still who want to run a proof of concept. And don't want to be too rude, but we're not a proof of concept anymore. We've been doing this for 10 years and we know it works. We've been involved in many different industries across the world, lots of different cultures, lots of different machine types. So I don't think just to focus on a small number of machines for a proof of concept, does this work, is the right attitude to go. Um, One of the reasons as well, if you get a customer and say, right, we've got like 10 motors and we're going to try your software out on them, then my question to them is always, in the space of the time that you want to run a proof of concept, how many of those machines do you think will have an issue? And I've spent quite a lot of time in this industry, and I look at how customers interact with their machines over a period of time. And depending on the industry and the machine type, etc., most machines are intervened with maybe 2 to possibly 12% of the time over a year. So if you've got 10 motors and let's say you've got quite a high chance of intervening with them in the next year, that's possibly 10% in one motor, and it's in a 12-month period. So the likelihood of you seeing a good success in a 3-month window or something like that is going to be limited. So I would always urge customers to embrace the technology, to pick a subset of their machines, yes, but pick a nice large number of machines and to go with that. So machines that ideally to begin with, I would not necessarily choose the most complex machines, and you want machines that will be performing a similar task many times so we can compare the data, what the machine's doing now to what it was doing a month ago, 2 months ago, that sort of thing. So over a period of time, you get a good base level of what the machine's doing. I think that we have, or customers do face some challenges to access to good quality data. So we want data that will tell the software something about the condition of the machine and not necessarily just the process that the machine is undergoing. So if you've got machines that are, lifting different sizes of equipment, or they're moving different things around, or different recipes, etc., then trying to remove the noise from the process of that data compared to the actual condition of the machine, that can be a little bit tricky. I think customers need to look at the technology they've got and the compatibility. So there's a few systems out there that a company, so equipment manufacturer, might be able to sell a condition monitoring solution that will be just right for their machines. And that can be a really good way to get started. But then what happens in the following year when you want to move it on to a different manufacturer's type of machines? And the same sort of thing with hardware suppliers. If you've got a hardware supplier, they're sending sensors and they say, yeah, you can have these sensors, and they go with just our technology, then that's great if you only want to use those sensors of that particular manufacturer. But then if you want to embrace data from a different source, that can be a bit of a problem. We've always got to look at cost implications. So hardware is always going to have some capex cost. Obviously, there is the software cost as well. But if you want to, you can harvest existing data, but then that will require knowledge of how to get data out of that equipment. So do you have the in-house capabilities to access the data? And then I suppose the last part is, culturally, is your company culture willing to embrace the changes that a predictive maintenance system is going to ask them to embrace?
Yeah. And just going on your last point of cultural issues and cultural change within the workplace, this seems to be maybe one of the key challenges which does come up. And I think when it does come to predictive maintenance, you often do require this cultural shift within
Mhm.
organizations. And how do you think companies in the automotive industry are addressing this challenge?
I think companies have to embrace the fact that they will need to go on a bit of a cultural journey. The management buy a solution like Senseye, but it's not the management who will make the solution like Senseye a success or a failure. It's a key group of users, and it's usually maintainers or maintenance planners, somebody like that, who's going to be looking at the insights raised by the software and providing good feedback into the system. You're also going to need a mixture of skill bases in the early stages. So you do need, obviously, like the project management side of things to make sure tasks are getting done. You're going to need some form of ITOT type people who can actually get the data out of machines, or attach the hardware if you're attaching vibration sensors, current clamps, somebody who can interrogate PLCs. You need those people in the early stages of the deployment. But also you need people involved who know what they want to see out of the data. So again, in the early stages, we'll want a maintainer or a machine expert involved in discussing with the IT, OT type people what data they need to make sure that they know what the machine's doing. There's nothing worse than getting a load of data. We'll throw it at the algorithms to see what it tells the algorithms, and then the maintainer turns up and says, yeah, but we don't have a problem with that part of the machine or with that sort of data. And so you really need to have a methodology that involves the right people at the right time to make sure that you're moving the project forward in a nice manner, with everybody buying into it and everybody uh, embracing it. So you will celebrate your successes. You will celebrate the fact that, hey, we've got the machines like wired up. We're seeing data for the first time. And then when you have the first successes from the data, and you'll say, hey, we prevented some failures, or oh, it told us something that maintenance had done last weekend, but we saw it in the data. That's really good. So to try and get that sort of celebrating of the culture within the organization is quite important.
Yeah, it is very integral, to the whole project. So we just need to ensure, these challenges are faced correctly.
Mm-hmm.
But also, one thing I just wanted to highlight, just on your point, when it does come to organisations and cultural change, I do feel that there is this element of fear. You
Mm-hmm.
probably find this more, Peter, maybe from dealing with some of the customers and their challenges, but there seems to be this element of fear of change, I would say.
Yes, I think in some organizations that there are that sort of fear. And if I'm honest, there's not that much we can actually do from the outside. If people are frightened of the services that we're providing, it's going to take a lot to win those people over. In the first case, we really need to help drive the local management to you know paint the picture that we are implementing this technology, and the reason we want to implement this technology is because we want to increase production. We want to help to train the workforce, and a lot of what something like a system like Senseye does, it takes away the mundane tasks from people, but it then allows them to perform other interesting tasks on other machines. So instead of just going around and doing the daily checks on the machines that might fail often, you end up that part of your job gets automated, but then you can go and you can maintain other machines that, okay, they don't fail as often, but when they do fail, they still cause stoppage. So you can actually make the maintainers' lives less mundane, more interesting, I suppose. I've not actually seen this drive any uncertainty about jobs in the future, because what you are doing is you are making your company more competitive, and that's a win-win for everybody. So I haven't really seen too many issues with that sort of culture of fear. But then I suppose the projects I'm on, the customers are embracing this idea of changing, and we are going to not change our maintenance practices, but improve our maintenance practices and go on a journey. And it starts with where you are today, a plan to remove some of the more mundane tasks and to improve the efficiency of your machine. And then ideally, you take your maintenance team from firefighting and failure investigations into more proactive work. That means that they're generally having a more interesting and a less stressful life.
That's it. No, you hit the nail on the head with that, because I was just going to mention this, focus around improving efficiency.
Mm-hmm.
And I feel, organizations, as much as it is this topic around cultural change, there is many benefits with that. So it's a new way of working and ultimately making it easier for them with
Mm-hmm.
their day-to-day roles, and, measuring success and seeing success is always, one of the main elements that people within the organizations want to see very quickly. But we both know that it does take time. But once you do have a process, it streamlines and it just makes it so much easier to work more effectively.
Yeah, definitely.
So I just wanted to just moving on, Peter. Just wanted to see if you had any, real life examples of a company within the automotive industry that has seen measurable success when it comes to predictive maintenance.
Yes, I mean, we have a number of customers in the automotive space, and they all have a variety of successes. The probably for our biggest customer, still the area where they have the most successes is with their robots, reducing issues with those. I did have a look at their data from the last year, and they intervened in around 8% of their robots, so not a huge number. The average time avoided or downtime avoided, they said they saved, was around 4 hours per issue. So that did save them hundreds of hours of potential downtime. But also, they have changed their culture of how they maintain their robots. So before, they used to perform a lot of preventative maintenance. They used to take a lot of grease samples from the robots, and they would do that on a monthly basis. And so now they actually use grease samples when Senseye detects the early stages of a failure. They will then take grease samples to determine how long that failure mode is going to last. And that's because, one, we don't have, or they don't have an automatic way of sending the grease data to Senseye. Obviously, some machines you can have oil condition monitoring and that sort of thing, but we don't have it for their robots. We have a lot of successes across the whole organization. For our biggest automotive customer, I look back at last year, and they intervened in about 8% of their robots, and they saved around 4 hours downtime avoided per robot. So that saved them hundreds of hours of potential downtime avoided. But they have already undergone a cultural shift, and so as well as saving them downtime avoided, we do save them other costs. So one of the things that they did relatively early on is they reduced the preventative maintenance that they performed on these robots. They have a particular failure mode that takes typically like a 3 to 4 month failure from when Senseye detects the beginning of it to the actual failure. But this can vary dependent upon the weight of the robot arm, the weight of the tooling, what the robot's actually doing. So before Senseye, they used to take grease samples from their robots on a monthly basis. So they've cut that out now, so they aren't doing grease samples on every robot, but they wait for Senseye to say, okay, you have this particular failure mode starting, and then they use the grease samples just to help them plan when they are going to make the replacement of the particular component. So the reason for that is it's very easy to see the beginning of the failure mode in Senseye, but that doesn't necessarily mean it is optimum to change that part straight away, because you might have 3 or 4 months left of working life on that component. But the reason that Senseye can't be a little bit more accurate with this particular failure mode is that we don't have access to the grease samples because they are still manually taken. So they can put that information into Senseye, but it's still a manual task once Senseye alerts them to this particular failure mode. We, as well as, so we reduce the preventative maintenance. One of the other areas is if this particular company has a failure, then they have to investigate the failure, and they record, they dismantle the machines, etc., and they write a report about the particular failures, and they categorize that as about 16 man hours. So if we prevent a failure, then we also save them 16 hours of writing up failure reports. And when it comes to the cultural shift, most maintainers don't like writing up failure reports, so we can again remove that sort of mundane task from them, and again it helps to win them over. Another area that they have a lot of success is with servo welding guns. These tend to have a much shorter time span for alert to failure, so when the data starts to suggest that there's an issue with the guns, they will probably maintain those within the next week or two. And then we recently had a new customer, and they had some quite exciting wins on injection machines that were injecting insulating foam into car bodies. So these machines were used to inject the foam to sound insulate their machines. And we were going to discuss or record a podcast for this one a couple of weeks ago, weren't we? But unfortunately, that got postponed. So I'm going to advertise it in this feed. So it will be there in the next few weeks. We'll have a very exciting podcast where we are discussing with a Siemens colleague about how they implemented Senseye for their customer. I think it'll be quite exciting. Another good success kind of case study was a particular customer. They had half of their conveyors being monitored by Senseye and half of them were not. And they decided to do a maintenance cost analysis for a year. And when they looked at all of the hardware, the cost of monitoring the conveyors and Senseye, looking at any alerts, following them up, or going to the conveyors that were not on Senseye and using a handheld vibration monitor to just check vibrations, doing the preventative maintenance, that sort of thing. So they looked at all of the conveyors and they realized that the cost to have a conveyor on Senseye was 27% less to the business than having a conveyor not on Senseye. So I thought at the time, this is great. This is, for me, the perfect thing. I can go to their management and I can say, every asset you add on to Senseye saves your business money. And I thought, yay, I've won with this one. And then a few days later, I thought, hang on a minute. This isn't a fair comparison because they put the most troublesome conveyors onto Senseye first. So not only are we saving them nearly 30% maintenance costs on the cost to maintain these conveyors, but they've put the troublesome ones on. So the most troublesome assets in your organization are still cheaper to maintain than the less troublesome ones. So I thought that was quite a good, nice little example of a case study. But for customers who want to know, we've got, we monitor foundries, CNC machines, press shops, powertrain, paint shops, the RTOs that scrub the chemicals out of the exhaust fumes of the paint shops. We've got success criteria from, across the whole business, from a transformer that got struck by lightning one year to somebody not turning an AC onto an electronics cabinet that hadn't had any issues for 3-4 years, and then all of a sudden, boom, an alert in Senseye and somebody's fixed an AC and not turned it back on after fixing it, and so now everything's beginning to heat up. So yeah, we've got a lot of different success cases.
Yeah, no, that's great. That's really great to know. And just on, different types of success cases that you mentioned around automotive industry,
Mhm.
one part I just want to highlight is the fact that we can monitor pretty much. There's different types of assets
Yeah.
within the automotive industry. So this whole example of, the first thing that comes to my mind is obviously seeing a vehicle in a showroom
Hmm.
or in the manufacturing stage of, prior to it being in the showroom. There's this whole process of the car being assembled. So it does make you think from a perspective of just understanding it, that there's all these different assets which contribute to the end result of having a
Hmm.
vehicle. So it's interesting to understand. I feel like, that's just one element to highlight. Senseye Predictive Maintenance does support with many different types of assets within this
Yeah,
industry.
definitely. And within the suppliers of automotive industries as well. So, we have mining companies that produce the ore. We have the steel manufacturing that produce the metal, and then it's quite nice because we can trace some of that metal into our car plants, and we can see them in the press shop. Obviously, the press shops, then they go and assembly, welding, like I say, painting. Now being filled with foam,
Yeah.
uh, you name it. It's and it we've what we have done with our larger automotive customers is we've just never stopped with them. So they every year they have a plan. What shall we put on Sensei next? And some of them are great. I mean, one of the quickest data to successes we ever had was with some carrying devices that carry car bodies from one section of the plant to the other overhead. They whip along, and the customer spent a little bit of time discussing what sensing they were going to put on, and they implemented it, and then they put all of these carriers onto the system, so a few hundred of them. And when we looked at the data, there was a separation between the mean and the median type operating parameters, and then some were higher. So it was like, ooh, now that's really interesting. So let's look at the ones that are higher. So these weren't what we'd normally call any machine an asset. They were assets that were necessarily exhibiting um, movement in the data towards failure, but it was like, why are these outliers? And when they looked at these particular machines, they found that there was an oil leak through the stator of the motor, and so they were performing suboptimally. And so within getting the data into Sensei to having about 20 successes was within 7 days. So that's really good, but that's luck, obviously. But just doing this at scale, you have a few hundred of things in there, and then the curious side is like, well, why are those ones hotter? And they were measuring a stopping distance of these things. So why are they hotter? Why do they take longer to stop? And so you go and investigate, like, oh, look at this. That's really interesting.
Yeah, yeah. No, of course. And like we say about customers, each customer is different.
Hmm.
Their success cases are going to be very different. There's no one size fits all, because it really depends on what assets you've got which are running, and where you need the support.
Hmm.
So that takes me to my next question around, how long does it typically take for customers to see return on investment when it comes to predictive maintenance softwares?
So from a software point of view, then I would like to think if you roll it out at a large enough scale, okay, 3 to 6 months is not unachievable. So I would say, yeah, 9 months to get back the cost. The one area I would be a little bit more hesitant is saying it will obviously depend upon the any cost of hardware that you use for the rollout. And it also depends on what you're measuring. So we do have customers who, for example, we always talk about downtime avoided. Yeah, we'll cut downtime avoided 50%. But some customers, they're not looking at downtime avoided as their key success criteria. So they might want to be looking at being able to perform maintenance during the week and not just at weekends, where I'm sorry to any of my maintenance colleagues out there who like coming in on a weekend to earn a little bit of overtime, but sometimes when the businesses are a little bit strapped, they want to be able to plan that a little bit better. So being able to maintain during the week and not paying the time and a half for overtime. Obviously, we want to reduce the preventative maintenance. So if you're tracking that, you can reduce that by rolling out a system like Senseye. We should be able to save, like I mentioned before, about investigation reports, that sort of thing. You'll definitely get better parts utilization. You'll be able to manage your stores system a lot better. We did a project with some university and some parts suppliers in the north of England a few years ago, and they were talking about how the carbon footprint of spare parts, the bulk of the carbon footprint is through transportation. But if you've got a part that gets expedited because of a failure, then that carbon footprint goes from something like, I can't quite remember the numbers, but something like 40% to 90% of the carbon footprint of the part is just transportation because there's a failure. So if you can manage your business better, manage your maintenance better, then you're going to reduce your carbon footprint. And also things like asset life extension. I remember one customer a few years ago, and they were saying, we've been asked to roll this out, but to be honest, we don't have a downtime problem. Okay, we were chatting, and so how often do you replace these motors? Like, oh, well, we replace these motors every 6 months because once we had a failure after 7 months. And like, okay, so let's look at that. And I'm not saying, right, just never change these motors, but, well, let's look at the motors, the data, and let's look at the data, before you change it and maybe afterwards. And when you change one of these things, take it apart and see, did you really need to change it? And so you can start pushing out that asset life. So you can, leave it while it has a useful life. And then when you see it begin to deteriorate, then you can start to plan to change a part out, extend the asset life. But this sort of thing requires quite good KPI tracking. So we do have KPI tracking within Senseye, but it also that requires the customer to want to track that sort of thing and to have an idea of maintenance costs and how much they spend on preventative maintenance, etc., and then try to have a target to reduce that.
Yeah, I think it's just working collectively. You mentioned
Mm-hmm.
about, Senseye, we have really great capabilities to track KPIs, but that's also from a customer perspective as well. So I think when it does come to return on investment, it does vary. As you mentioned, it could be anywhere from three months to maybe 9 months or even a year, but the longer the better. I think these things really do take time when it does come to ROI. And sometimes there is that assumption or expectation where customers just want the ROI just to come in straight away. And
Mm-hmm.
we have to, be mature in this field, especially around predictive maintenance, that it does take time. It
Mm-hmm.
needs to understand the assets and get to know what's going on. Hence why, it can help to support and predict when there are going to be failures
Yeah.
within that asset, so customers are aware. So no, it's interesting to understand like ROI is something which is varied across different industries, and not just only in the automotive, but it depends on each customer and
Mm-hmm.
what they currently have implemented at the moment as well.
Yeah. And if you can really maintain a piece of equipment very, very well and it won't fail, but then your maintenance costs can be huge. So there's always going to be a balance between one area of the business and the other area of the business. And then sometimes it's also about the design capabilities of the piece of equipment. Are you using it to the full extent of its capabilities or sometimes above? Or are you using it well within its design capabilities? And if you're using it well within, then obviously it will last longer.
Yeah.
So yeah, it's always a bit of a movable feast.
Yeah. Yeah, of course. Um, I've got a really interesting question, Pete, just around software perception.
Mm-hmm.
And I'm really curious to understand, do customers generally view predictive maintenance solutions as operational necessity or a competitive advantage?
Oh yeah, I think they would probably start their journey by thinking it would be a competitive advantage, but after uh, hopefully a short time using us, they will realize that it actually becomes operational necessity. But I don't know. I'm not convinced it's a competitive advantage anymore. I think it should be industrial norm. There are so many customers out there using either Senseye or a solution like us that I believe if you haven't started your journey, you are behind the times and you need to play catch up.
Yeah, no, I agree with your points. When it does come to this competitive advantage, personally, from my perspective, I would maybe say customers did see it as a competitive advantage, but this is
Mm-hmm.
maybe going back, maybe in time, to the current, situation of what's going on, especially around us with technology, with the, AI and essentially making it so much easier for you to focus on what your assets need support with.
Mm-hmm.
It's interesting. It's just an interesting discussion to have. I mean, I could go and spend hours talking about that topic around it, but you're right in saying it is something which is a operational necessity
Yeah.
because it does ultimately improve efficiency, and you've got so many other benefits
Yeah.
with having a predictive maintenance solution to support.
Yeah. I mean, from improved production to better supply, inventory management to just better utilization of your human resources, better utilization of your equipment, your software, everything. It can have a really big impact on a customer's business.
Yeah, yeah, no, I agree with you. And in terms of just touching into
Mm-hmm.
uh, training as a topic and adoption. So, in terms of training, what role does that play in helping automotive companies adopt and fully utilize predictive maintenance tools?
Okay,
Uh,
so yeah, I feel that the Sensei as an application is very easy to use. So I would expect a customer to be up and running with like a 30-minute tutorial. Obviously, we have help centers, we have videos, we have training guides, and we will deliver either in person or remote training. But 30 minutes is probably enough, I think, to get going because you're never going to teach somebody from zero to expert in one session. So there's no point trying to stretch it too much. So we tend to give people 30 minutes. And then when we roll out an initial deployment, we'll have maybe 6, 8 meetings with the customers and we will guide them through what Sensei's telling them, the alerts that the system's raising, any potential actions that they need to do. And during that time, we will guide them and train them to become, the expert users that they need to be. But what are the areas? And like I say, I wouldn't really want to call it training, but I feel that the part of the cultural side of things is about how to run a successful predictive maintenance project. And then we have documented that sort of thing with our, we call it the Senseye knowledge platform these days. And it's about at different stages of the PDM project, who you have to have in the room to make sure that you get the most out of the initial discussion about what assets you're going to put on the system, the type of people involved in the conversation to make sure you get the right data from those assets, that sort of thing. And this has been built from years of, with a long time ago, but customers will say, right, we will monitor these machines because these machines have data because they're newer than the other machines. And so being newer, they often didn't fail as frequently, and often the data would change on the new machines because everything around them had failed or had stopped because there'd been a failure, and the area that was causing the customers' problems was not within the Senseye system. It was not monitored because they didn't have any data on it. So those sorts of deployments, we've kind of learned from that, and we like to guide our customers to, like, this is how you do it. And I would say, please listen to us on this, because it's not just about I can get data from this machine, or it's not that, that shop over there, they have great success by monitoring those machines, therefore we will start with that. Because if you don't have a problem with those machines in your shop, then you're not going to have success from monitoring those machines. So where do you have your issues, and what data is available or can be reasonably cheaply acquired in order to tell you something about those failures, and again, helping you as a maintenance customer to avoid those problems.
Yeah, yeah. No, you're right. And it is, around selecting the right assets to start with,
Mm-hmm.
just wanted to reinforce, obviously, getting the right data from the customer. And ultimately, this will have a massive impact on how quickly the project does become successful.
Yeah.
So, like you mentioned, the Senseye knowledge platform, it's really, really useful resource to have a look,
Mm-hmm.
and just gain more guidance around this topic. So that's really great to have, to support our customers with their successes.
Yay.
So,
Definitely.
and then just moving on to just another topic I wanted to discuss is data collection and analysis, which are very integral to predictive maintenance.
Mm-hmm.
So, how are customers' attitudes around data privacy and ownership impact adoption in the automotive industry?
Yeah, I feel in the automotive industry there's less resistance about sharing machine data to a cloud. I have seen in some other industries where customers get a little bit worried, but I think in the automotive industry, they realize that sharing a motor current is not going to tell you anything about the type of car that's being manufactured. So I haven't seen as many issues within the customer about uh, sending data to Sensei per se. Now, they will all have their preferred methods, and obviously the customer IT departments will be involved to scope out their preferred method of how they send data to us. And we accept data from many different sources, many different methods. And actually, from a lot of customers, we will start off with one way of transferring data, and then as that relationship develops, or maybe as we move from one shop to another shop, the IT skills within that shop will be slightly different. And we'll say, well, can we send you data in this way? And we're like, yeah, okay. And so often we'll end up with 4 or 5 different data transfer methods from the same customer into our application, and that's all fine with us. We really do not mind where the data comes from, just please send us it. And then I suppose on the flip side of that is, how do they access Senseye? And because we are web-based, the good thing about that is the customer's IT department can manage what browser you use. Basically, we don't mind if it's Chrome or Edge or Safari. A lot of our customers will now have different handheld devices as they move around the workshop. So being web based is a real bonus. We also do integrations with customers' own systems, but I would suggest that's like the next stage, not the first stage of any deployment. But yeah, we are very, very flexible with how customers interact with us.
Yeah, I was just gonna say that there's this element of flexibility, which is great. And also just to highlight other, off the shelf connectivity solutions such
Yep.
as Insights Hub, Industrial Edge, Brownfield Connect.
Hmm.
So there are quite a few, if anyone is starting from scratch, to have
Definitely.
those to have that resource available. Sorry. So, but yeah, definitely flexibility with Senseye Predictive
Mhm.
Maintenance.
Yeah, and I
And
think so. Talking about those off-the-shelf connectivity solutions, I was told something only about a week or so ago, which I found really interesting. When we analysed the time to data for our projects, we realised that if a customer's IT department wants to send us data themselves from a bespoke solution, then you can add 4 months to the time frame of the project before it really gets going. So I would definitely say to anybody new to this is have a conversation with one of our Siemens connectivity colleagues. And I am not biased, whether it is Insights Hub, Brownfield Connect, or whatever. Anything that can send data to us is a win from my point of view.
yeah, and that's also just great that we have this integration,
Hmm.
some of these partners that we work with from a connectivity solution,
Yeah.
perspective. So yeah, definitely, I guess it's all about the data and getting the correct data, and also just reinforcing just to make sure that we do have the right asset.
Hmm.
So, but having that, that 4 months minimum to support with the initial phase probably, really does support customers who are looking to understand how it can help.
Yeah.
Yeah. So, and then also, just around customer expectations, do
Hmm.
you feel that, customer expectations around predictive maintenance softwares have changed or are changing, or, is there something that they are demanding now that they didn't before?
I feel that they're possibly getting a little bit more of a collaborative approach with the system architecture than when we first started. So when we first started, now maybe this is back before Siemens acquired Senseye. We would say we were like data source agnostic. We didn't care what data source the customer used, just send us data however you want to send us data. That's great with us. And customers would have or the customers who scaled with us the quickest, you would usually have their own data source or a data lake or a nice big database, and they would have data that they will be willing to send to us. I feel that that has definitely changed, and with the customers that we've been with a long time, their IT infrastructure has often developed, and they're much more collaborative with where the data's hosted and stored and that sort of thing. But I also feel that these days that there are more customers are willing to collaborate with that side of things from the get-go, and maybe it's because they realize they're a little bit behind. So that's definitely one area that I think is changing. I feel that the recent language models that have come onto the market, that's really prompting people to open up a little bit more about knowledge sharing, and it's also breaking down a few of the technical barriers. We've got a chat bot within the application now, and one of the things I realized recently is that it takes me as a customer success manager building up the relationship with the customer. It takes me quite a while before a customer will say to me, Pete, I just don't understand what this data means. You're like, okay, well, yeah, I can help there and I can explain. And when usually it's because whoever is talking to me was not involved in the asset discovery side of things and why they are monitoring those particular machines, etc. So I obviously I have access to the reasons behind all of this stuff. So I can say, yeah, it's because of this and because of that. But people open up to a chatbot pretty much straight away. And I know a few customers when I've seen their conversations and I say, oh, we can put on some training for this. Or they're like, oh, no, I was just testing the system. But, I really think, that people do not mind asking a chatbot a silly question. And obviously there is no silly question, because if you're looking at data in a chart and you're thinking, I don't know what this means, then just ask and we can collaborate. So the chatbot side of thing is definitely helping. The one area that I really have seen, so within Senseye, we have had user feedback on machines for years and years and years, often written, but now customers are seeing the language models reflect back to them the type of information or type of words that they use when they are interacting with the system, and that's actually making the customers give the system more information than they used to, because now it's being reflected back, and they can say, okay, well, I tried X, then Y, and then Z fixed it, and then the next time Sensei gives them an alert, or like, oh, you should try Z because last time you did X and Y first, and they're like, whoa, this is amazing. So that sort of thing as well, that's really helping to get knowledge out of the customers, just because they are seeing it reflected back to them, and it's allowing them to become, again, a little bit more productive.
Yeah. No, I completely agree with you. And your point that you made around the chatbot is interesting, isn't it? I
Mm.
feel, just in, today's world, should I say, chatbot is something which is used heavily just outside of work, and people
Mhm.
use it for various different purposes. But having that's interesting what you mentioned around, how customers are more likely to open up to the bot
Yeah.
quite quickly, and that itself is very empowering. So it just reinforces how, the chatbot that we have within the Senseye Predictive Maintenance platform, it's very intuitive and it's very knowledgeable. So it helps again to reinforce this improving efficiency, and
Mhm.
just getting, sometimes you might have to wait to speak to someone when it comes to human interaction, and that's normal. But having the benefits of this chatbot just make it very easy to access.
Yeah.
So any information that's required from the customer, they can essentially just quickly type it, just like
Mhm.
you would with a text message, and you get a response back.
Yeah.
So,
And it's been really interesting watching our researchers and the data scientists interact with these chatbots, and we are a long way ahead of I guess, the industrial trends with it. I mean, one of the things that made I suppose, the news recently, I don't know, but like AI's hallucinating. Now, our guys were onto that probably just over a year ago, and so when you interact with the Sensei bot, it will actually give you an example. If it says, well, in the past we've seen that this issue was caused by this, then it will give you a link to where you said in the past that this case has led to downtime avoided, and or it could be because of maintenance issues, and these are your work events, and it will give you those. So having like referenceable actions from the chatbot, I think, is really powerful. And yeah, if anybody's not used it yet, definitely start to interrogate the chatbot.
yeah, no, definitely ask your questions and get the
Mm.
information that you need around your assets.
Yeah.
Okay, perfect. Well, Pete, I have just one final question just to wrap up this really interesting topic that we've been discussing. And it's focused around the future of PDM, predictive
Mhm.
maintenance, within the automotive industry. How do you see predictive maintenance evolving in the automotive space? And are there any new features or capabilities that customers are asking for now, in particular?
Yeah, I feel the the main area is still, I suppose, the main new area is still with the language model type things. So they want to feed the system a lot more. So we're just bringing out the ability to upload maintenance manuals and things like that. So you can ask the chatbot, okay, what are the recommended procedures for performing this maintenance? So they can save them searching their own material. So that's really powerful. The learnings across not only the site, but when you are multiple site organizations, so being able to pick those learnings up from an area of the hierarchy that you've probably never been in before. So that side of things, really good. Certainly, we are bringing out some more sophisticated forecasting algorithms based on some of the newer type of algorithms that are out there. That's quite exciting to be able to have more realistic forecasts for what your data is going to be doing in the future. I'm really excited by what's coming up. I think it's going to be an exciting another 12 months within the old Senseye world.
Yeah, no, me too. It does seem very, very exciting, especially around the automotive industry.
Mm-hmm.
I mean, it's already evolving now with some of the vehicles which are being created,
Yeah.
Around hybrid and it's just I find it personally. I've always found the automotive industry very appealing, and it's even more
Mm-hmm.
exciting from a predictive maintenance perspective because there'll be maybe new assets, within the customers that we look after. There'll be new assets which will then be monitored as well. So
Yeah.
I completely agree with you around this, sharing, learning, etc. So it'd be interesting just to see how it evolves over the
Yeah.
next couple of weeks.
And then
Um,
one thing I'd like to end on, which I was going to mention earlier and then I slipped, was the quote from one of the VPs when my colleague in America was having a beer with him. And he was saying that in the early stages of the Senseye deployment, he says, our downtime is reducing, our production is better than ever before. But you know what? Since we rolled out Senseye, people on the line are just happier. And it's like, who would not want to bring happiness to their customers? You're reducing their stress, you're helping them to plan and organize their work better, and you're just improving their working lives. I think it's brilliant. So if you haven't started your journey, please start soon and come see us.
yeah, no, that's perfect. What a lovely quote to finish this episode on.
Hmm.
It's really lovely to hear that from a customer perspective as well. Like I said, it's all about collaborating and working together. And once you start to understand what the goal is, I think that's really lovely to have that combined together
Yeah.
and building those relationships. So yeah, but this has been absolutely amazing, Peter. Thank you so much for sharing your expert insights into
Mhm.
this topic of predictive maintenance and automotive industry. And look forward to the next one in the series around this
Yeah.
topic.
Well, thank you very much for having me.
Thank you. Please like and subscribe to all major podcast channels and find out more about Senseye Predictive Maintenance at Siemens.com.